Next is when you have the comparison between the TCP and OSI. Okay, so some of the concepts related to OSI model: services, interfaces, and protocols. So when we are talking about the comparison, we'll be doing in terms of services. What services are provided, what interface, what is the meaning of interface, what is the role of interface, what is the role of protocols. So first we'll see that, then we'll see the TCP/IP versus OSI. So in case of services, every layer will perform certain task or certain service. So already we have seen in the 7-layer architecture, so the role of each layer, like physical layer role, so bit stream is being converted into pulses in terms of cable media, that is wire electrical pulses, fiber optical pulses or light pulses, wireless radio waves or electromagnetic likewise. So every layer is having certain tasks, certain performance, certain service. So it is based on the services, and the service will be provided to its upper layer. For example, physical layer will provide the services to its upper layer, data link layer. Data link layer will provide services to network layer. Network layer will provide services to transport layer. Likewise, presentation layer will provide services to application layer. So application layer will request for service. Okay, application layer is going to request the presentation layer for service. So I want to send this information, please take care of this, please send it. So likewise, it is going to request, upper layer is going to request its lower layer for service, and the lower layer will provide service to its upper layer, whether it is TCP/IP model or OSI model, irrespective of the model. So every layer will provide service to its upper layer, and every layer will get the service from its lower layer. So that is service. Okay, so the meaning of this, every service, only the what the layer can do, but how it does, it doesn't matter. So what is needed is a layer has to do the service, but how it is going to do the service doesn't matter. Okay, how the service is being accessed doesn't matter. So only thing is job get done. So that is the meaning of the services. So services will be, every layer will provide services to its upper layer, and every layer will request services from its lower layer. Okay, so an interface is nothing but, suppose this is say layer 5 and this is layer 4. So between layer 5 and layer 4, what is called interface. Between layer 7 and 6, an interface. Between layer 6 and 5, an interface. Between 5 and 4, an interface. Between 4 and 3, an interface. Between 3 and 2, an interface. Between 2 and 1, an interface. So interface is exist between two adjacent layers. Okay, so the interface will tell how the above layer is going to access the service in the lower layer. Okay, so this interface will inform the upper layer how to get the service from the lower layer. Okay, that is one task. And the second task of the interface is, so what parameters are needed, or what parameters are needed, and what are the expected results from the service or from the lower layer. So interface will tell that to the upper layer. Okay, but interface is not going to give the information to upper layer how the job is done. That is not being informed. What type of job is done, that is informed, but how it is get done, that is not informed. Okay, interface will inform the upper layer what services upper layer can get from the lower layer. So using those services, for to use those, what parameters are needed, what type of results that can get. So these things it is going to inform to the upper layer. Interface is going to inform to the upper layer, but how the service is being done, so that information interface will not provide to upper layer. So that is about the role of interfaces. Then the role of protocols. So the protocol, every protocol will do certain task, certain job. Okay, every protocol will have its own functionality, its own task. It is going to perform that task. Okay, so depending on the task, the particular protocol is being loaded in a particular layer. So depending on the task, a protocol will be fit into a particular layer. For example, if we have a protocol like RIP, Routing Information Protocol, or OSPF, Open Shortest Path First. So what these two protocols does, they are going to gather the routing information from their neighbor routers, and it is going to keep that information in a routing table about routing information about neighbors and their neighbors likewise. So that the job is creating the routing table. The creation of the routing table is the task of network layer. So that is why the place for the RIP and OSPF is network layer or layer number 3. So they sit in the layer 3. Okay, so that is the meaning of protocols, where they are going to sit. And in this particular RIP and OSPF both does the similar task, gathering the routing information. Both can be available in network layer. So depending on the requirement, so both can be available in that. User may use any one of that as per the need, but both does the similar task. Okay, so it doesn't matter whether we are whatever expected information, whether we are getting it or not. That is the matter. So as for that, whether we are using RIP or OSPF doesn't matter. So which protocol we are using doesn't matter, but we want the expected result from that. So as long as we are getting, so it doesn't matter what protocol is being used. Okay, and so I can change any protocol or I can remove any protocol from any layer, but doesn't make the performance change in other protocols in other layers. Suppose if I remove RIP from the network layer, but the protocols of transport layer doesn't get affected with that, or protocols of data link layer doesn't get affected with that. Okay, if I change anything in the network layer protocols, that doesn't change the environment of transport layer or environment of data link layer. So those protocols, because every protocol is having its own functionality, it doesn't get affected by other protocols. So that is why if we remove any protocol or we change any protocol from a particular layer, it doesn't change the other layers softwares. That is about the meaning of protocols and role of the protocols. Okay, next one, see the OSI reference model and TCP/IP reference model. So OSI reference model, first the model is being derived, the layers are being defined, the layers are being derived, then the protocols are invented for the layers. Based on the role or function of the layer, the protocols are invented and they are fixed into that layer. So this is what is followed in OSI reference model. Whereas in the TCP/IP model, first protocols are derived or invented, then the protocols are being placed in appropriate layer. Okay, that is what the TCP/IP did. Because of this, the TCP/IP model is being fast designed and it is becoming popular in the network area. The second point between OSI and TCP is, so in case of OSI, no problem with the protocols. Any other stack protocols can be fit into OSI model. Like if you are having the Apple Talk protocol suite, IBM protocol suite, Novel Network protocol suite. So any protocol suite, you can put it into the OSI reference models. They fit into OSI models without any problems. But whereas in case of TCP, it is not true. In case of TCP, it is not true. So TCP is having its own proprietary protocol suite. only those protocols will sit into TCP/IP model. Other protocol stack will not be supported in this. So that is second point between OSI and TCP. And the third is, in case of OSI, the network layer is having protocols supported for both connection oriented communication and connectionless service. Okay, in OSI model, the network layer will provide connectionless service and connection oriented service. Both the services are available in OSI model in the network layer, but the transport layer in the OSI model is only connection oriented. So transport layer of OSI model is providing only connection oriented services. So what we can say, so network layer will provide both connection oriented and connectionless services, and transport layer only connection oriented service in OSI model. Whereas in TCP/IP model, the network layer will provide only connectionless service. So whatever protocol we have seen in the previous slide, IP in the network layer or internet layer, so that IP is a connectionless service. Okay, whereas OSI model is having both connectionless and connection oriented. And in the transport layer, TCP is having both connectionless and connection oriented. TCP connection oriented, TCP connection oriented, UDP connectionless. But whereas in case of OSI, only connection oriented service. So that is another point to be considered between OSI and TCP. These are about this. Now, TCP is becoming more popular compared to OSI because the everywhere TCP model is being referred to. See, for example, the present internet following the TCP/IP model. The present internet is using TCP/IP reference model, so that is why TCP become more popular, and OSI model has not become popular because only the model is being derived and some protocol are invented, but practically the usage of OSI model is being not popular. Okay, but it is going to support almost all types of protocol suites. So it is till now it is being used as a reference model, but not as a practical usage model. Okay, that is one thing between the OS and TCP. That is why so OSI model is not successful. And another one is, in OSI model, no special mechanism for providing the reliable connectivity for sending the information between two hosts. So there is no secure connection between sender and receiver in case of OSI model. It is not yet derived till now. But whereas in case of TCP/IP model, a three-way handshaking mechanism is available between sender and receiver to identify so exact sender and receiver, who is sending, who is receiving, whether it really is the authorized to send or not. Likewise, so that security aspect is there in case of TCP, but not there in OSI. That is why OSI is not popular